Think about all the tech we use every single day. Your phone, your computer, even, I don't know, smartwatches. There's this invisible thing inside, right? A
Yeah.
core material making it all work.
Exactly. And that's what we're digging into today. Semiconductor wafers, that invisible backbone.
Right. We're doing a deep dive based on a report from Cognitive Market Research.
Yep, a really detailed look at the semiconductor wafer market.
So our mission here is to really get under the skin of this industry. Who are the big players? What's the situation right now, like early 2025? And what's driving all this growth?
And we've got the data market analysis, company revenues.
Hmm.
The report came out December 2024, updated just last month, so it's pretty fresh.
Okay, so what are the headline numbers? How big is this market?
It's substantial. In 2024, it was valued at, let me check, USD 23,142.5 million.
Wow. 23 billion.
Yeah, and it's projected to grow quite a bit. They're forecasting USD 30,589.4 million by 2032.
Okay, so what's the growth rate on that?
That works out to a CGR, a compound annual growth rate of 6.60%.
Mm.
Pretty healthy growth.
For anyone maybe not super familiar, can we just quickly say what these wafers are?
Sure, absolutely.
Yeah.
Think of them as super thin discs, usually made of silicon. They're the base material, the foundation, where manufacturers build integrated circuits,
Yeah.
microchips.
Got it. So no wafer, no chip.
Pretty much, no chips, no modern electronics. They're absolutely fundamental.
And it sounds like demand is just booming. What's pushing this 6.6% growth?
Well, it's a mix of things, really. First,
Hmm.
just general digitalization. Everything's going digital.
Right.
Then you've got the Internet of Things, IoT devices everywhere, all needing chips.
Okay.
Plus, the huge need for more processing power. Think AI, massive data centers, cars becoming computers on wheels.
Yeah, the automotive sector's transformation is huge.
Definitely. And don't forget 5G rolling out globally. That needs advanced semiconductors. And of course, constant progress in AI and machine learning itself. It all feeds back into needing more and better wafers.
Okay, so a massive market, loads of drivers. Let's talk about the companies then. Who are the big players really shaping this?
The report points to a clear group at the top. You've got Taiwan Semiconductor Manufacturing Company, TSMC, everyone knows them.
Mm-hmm.
Then Samsung Electronics, Semiconductor Manufacturing International Corporation, that's SMIC over in China, United Microelectronics Corporation, or UMC, and Global Foundries. Those are kind of the big five manufacturing powerhouses.
The titans, you might say. But the report also mentioned emerging threats. Sounds dramatic. Who are they?
Yeah, maybe a bit dramatic, but it highlights the competition. While those five are dominant, there's another strong group pushing hard. Companies like Shinetsu Chemical, SUMCO Corporation,
Right.
Siltronic AG, SK Siltron, GlobalWafers, different from GlobalFoundries, mind you, Okmetic, WaferWorks, Fujimi Incorporated, Virginia Semiconductor, AEMC Instruments. Quite a list.
So it's not just the big five. There's this whole other layer of competitors. How do we actually compare these companies? What makes one a leader and another an emerging threat?
Good question. The report uses several criteria. The most obvious ones are revenue and market share. That gives you a baseline, right? Financial muscle, market penetration.
Sure, the bottom line.
Exactly. But then you look at their product portfolio. What kinds of wafers do they make? Just standard silicon. Or compound materials, specialty stuff. What are the features, the quality?
Right, what they actually sell. What else?
Technology. Innovation is absolutely key here.
Yeah.
Are they using advanced photolithography? That's the process for printing the tiny circuits.
Okay.
Are they doing 3D integration, stacking chips? And crucially, what node processes can they handle? You hear about 7 nanometer, 5 nanometer, even 3 nanometer now. Smaller means faster, more efficient chips, generally.
Got it. The smaller the better, basically.
In many ways, yes.
Yeah.
Then there's global presence. Can they scale up production globally while keeping quality super high? That's vital.
Makes sense.
And, of course, R&D spending. How much are they investing in future tech? That tells you a lot about their long-term prospects. Oh, and partnerships. Strategic collaborations can really boost market reach and product development.
Okay, that's a really helpful framework. Let's use that and zoom in on the top five, starting with the leader, TSMC.
Right, TSMC. They are, without doubt, the dominant force, known globally for just cutting-edge manufacturing. In 2023, their total revenue was huge, around $76 billion US.
76 billion. And how much of that was wafers?
The report estimates about 30 billion specifically from the wafer market, and that gave them, get this, roughly a 45% market share in 2023.
Wow, nearly half the global market. That's incredible. How do they do it?
It's really that relentless focus on leading-edge tech. They're masters of those advanced nodes we mentioned, 5 mm, 3 nm, pushing the boundaries constantly.
So they make the most advanced stuff.
Exactly, which is why companies like Apple, AMD, Qualcomm rely on them. Huge R&D investment fuels this innovation.
And they operate globally, not just Taiwan.
Correct. They have fabs in Taiwan, obviously, but also the U.S., China, and they're expanding more in the U.S. right now, diversifying and meeting demand.
Okay, TSMC, clearly the leader. Let's move to Samsung Electronics. Huge name, but also big in wafers.
Absolutely. Samsung's a giant all-around. Total sales in 2023 were about USD 240 billion. Out of that, wafer production accounted for roughly 25 billion.
So still a massive amount. 25 billion, what's their market share?
That puts them at around 20% market share, a very significant number too.
And what makes Samsung stand out in the wafer game?
A big thing for Samsung is their vertical integration. They make wafers for memory like DRAM, NAND flash, where they're very strong logic chips, specialized stuff, but they also use a lot of these in their own phones, TVs, etc.
Ah, I see. So they're their own customer, in a way.
Exactly. Gives them advantages in supply chain, maybe costs, and like TSMC, huge R&D,
Yeah.
pushing advanced tech like 3 nm and 5 mm. Strong global presence, especially anchored in South Korea, and they're really targeting growth areas like 5G, AI, IoT.
Okay. Next up, SPINS makes Semiconductor Manufacturing International Corporation, the biggest in China, you said.
That's right. SEMSMI is China's largest foundry. Their 2023 total sales were around $8 billion, with about $4 billion of that coming from wafer production.
Okay, so 4 billion from wafers. What's their share?
That gives them about 11% of the market. So smaller than TSMC and Samsung, but still a very important player.
And their focus, what kind of wafers?
They produce a pretty diverse range.
Yeah.
Logic chips, power devices, analog semiconductors. They've also made strides in more advanced nodes like 13 mm and even 7 mm capabilities. Crucially, they are vital for supporting China's own tech industry, which is a huge priority there.
Right, that domestic demand must be huge.
It is, and they're expanding their fabs in China rapidly to meet it.
Okay, fourth on the list was UMC, United Microelectronics Corporation.
Yep, UMC, another major global foundry. They specialize in advanced wafers too, for logic, mixed signal chips, power management ICs. Their 2023 revenue was about 7.5 billion total, with roughly 2.2 billion from wafer production.
2.2 billion, giving them what share?
Around 7% market share.
And what are UMC's strengths? What makes them tick?
They offer a really broad range of process technologies, not just the cutting edge like 5 mm, but also very established reliable nodes like 28 mm and 14 nm. That caters to a huge variety of applications: consumer electronics, automotive, industrial stuff.
So they cover a wider spectrum, maybe?
Kind of. And they're often seen as offering good, cost-effective manufacturing solutions. They're global two fabs in Taiwan, Singapore, China. Plus, they're investing in future tech like 3D ICs and advanced packaging.
Okay, and the last of the big five, Global Foundries, U.S. headquartered, right?
That's correct. GlobalWafers, or GF, a leading foundry based in the U.S. providing advanced fabrication. Their 2023 revenue was about $9 billion total, with around $3.5 billion coming directly from wafer production.
3.5 billion, so their market share is.
Around 9%, so slightly ahead of UMC behind CIMIC. They have fabs in the U.S., Germany, and Singapore, serving a really diverse set of industries.
And what's their special sauce, their focus area?
GF often highlights what they call differentiated technologies. Things like specialized processes for RF radio frequency chips, essential for wireless.
Okay.
Also embedded memory, and automotive-grade chips that meet those really tough reliability standards for cars. They're investing in nodes like 12 mm and 7 mm and have a strong position in those growing areas like AI, 5G, and automotive. They also make a point about their commitment to sustainability in manufacturing.
Okay, that gives us a really solid picture of the top five. Let's pivot back to those emerging threats. Who should we be keeping an eye on?
Right, the challengers. The report highlights several key ones. SEMCO Corporation from Japan.
What's their angle?
SEMCO is big in the actual silicon material itself. They focus on really high-quality, large-diameter wafers, the kind you need for the most advanced chips. Lots of R&D, especially focused on the Asia-Pacific market.
Okay. Who else?
Siltronic AG from Germany. They also specialize in high-performance silicon wafers, but have a strong emphasis on being eco-friendly in their manufacturing. They've got sites in Europe and North America.
Interesting. Sustainability angle. What about SK Siltron?
From South Korea. They've been making good progress in both 200 mm and the larger 300 mm wafers, which are key for the leading edge stuff. also known for solid supply chain management, which is super important, as we know.
Definitely. And GlobalWafers, not Global Foundries.
Right, GlobalWafers, based in Taiwan, so really focused on expanding their capacity, especially in Asia and North America, to meet that surging demand. They offer a wide range of sizes and are known for working closely with customers, being quite agile.
Customer-centric. Okay. And the last one you mentioned was Okmetic.
Yes, Okmetic from Finland. Their niche is high-quality silicon wafers, specifically for MEMS, those tiny mechanical electrical systems and sensors.
Ah, like the sensors in phones or cars.
Exactly. They do a lot of customization for automotive and consumer electronics customers. A specialized player carving out a nice spot.
So it really sounds like these emerging companies aren't trying to beat TSMC at their own 3 nanometer game necessarily.
Not always, no.
But they're focusing on specific materials or sustainability or particular applications like MEMS, or maybe just being really flexible for customers.
Precisely. They're challenging the big guys through targeted innovation, strategic capacity increases, and really focusing on market segments where they can offer something unique or highly specialized. It makes the whole market much more dynamic.
It really does. So if a new company wanted to jump into this incredibly competitive space, what would they need to do to succeed based on this analysis?
It's tough,
Yeah.
obviously, but the report suggests a few key things. First, technology. You need something cutting edge. Maybe ultra-thin wafers, or new high-performance materials, or special coatings. Some kind of tech advantage,
So innovate or get out, basically.
pretty much. And you have to figure out how to scale it cost-effectively. You can have the best tech, but if you can't make it efficiently at volume, it's hard to compete.
Right. Scale and cost matter hugely. What else? Partnerships, location.
Definitely. Strategic partnerships with the big chip designers or manufacturers can be crucial for market access. And yeah, location matters. Being present in high-growth regions, Asia, North America is key.
Okay.
And increasingly, sustainability is a factor. Investing in green manufacturing isn't just good PR, customers are demanding it. Plus, targeting those hot emerging applications, automotive, AI, 5G with tailored solutions can be a good entry point.
So it's a mix. Tech edge, efficiency, smart partnerships, right location, sustainability, and targeting the fast-growing applications.
Exactly. It's about balancing all those things.
Yeah.
Innovation, operational excellence, and smart strategic and geographic moves. That's the recipe, complex as it is.
Okay, let's try and bring it all together then. What's the single biggest takeaway for our listeners from this deep dive into the semiconductor wafer market?
I think the main point is just how vital and dynamic this market is. You have these established giants, sure, but it's not a closed shop. There's real competition driven by these agile, innovative, emerging players.
And underlying it all is just this relentless, almost insatiable demand for more powerful, more efficient semiconductors, powering everything from our pockets to massive global infrastructures.
Absolutely. That demand fuels everything. And for any company in this space, whether a leader or a challenger, continuous innovation in how they actually make these wafers, plus smart strategies for global expansion, are just non-negotiable for thriving.
It really makes you think. On that note, consider this. How will all these ongoing improvements in wafer technology shape the next wave of innovation, not just powering today's gadgets, but enabling things we haven't even dreamed up yet? What possibilities does this unlock down the road? And looking at the companies we discussed, the giants, the specialists, the challengers, who do you think will really be driving that revolution in the years to come? It's a fascinating problem to ponder.